Hello, welcome back. So this is the third lecture for chapter 21 about hashing. And in this lecture, what we are going to do is we are going to discuss the implementation of HashMap. And we are going to use the linear probing, okay? For the implementation. And if you recall, linear probing is one of the strategy to deal with the collision issue. Okay. So, so this is the second coding example in this chapter. So it's a Java hash map example. There are four files. We have a player class and a hash map interface and a class that implement the interface and a driver. Okay. And if you recall, the first example is a hash table. So similar concept for the hash map. Okay. So here, the map in Java is for key value pair. Okay. And for the map over here, what we discuss is a hash map. Okay. And if you recall in our previous chapter discussion, we also did there another called tree map. Okay, for tree map, it supports sorting. Okay, and for the hash map, so this whole chapter is about hashing. Okay, and the benefit for hashing is a quick lookup. So efficient lookup. Okay, very general speaking, it's order of constant. Okay, but it also depends on the implementation. Like for the implementation using linear probing, it may not, so for all of the cases, it may not always order of constants. It depends. Okay, so that's just very general speaking about hash map, its order of constant. Okay, and so this is the general idea. So over here, when we discuss the hash map, okay, so similar concept like the first example about hash table, okay. So it's a collection of maps. So the key value pair uh, pairs. Okay, and then it involves how we add. Okay, how we do update, and how we do search, and how we do remove operation. Okay, and because it's the map concept, it's a key value pair concept. So key is very important. Okay, and so we the advantage for key, as we already mentioned a number of times, is the efficient lookup. Okay, so in this example, let's first take a quick look of this player class. Okay, so this player class it has the name, team, position, height, weight, and age of those information. Okay, and quite straightforward. So we have player set and get methods. We also have toString equal And the important one in this chapter is regarding override equal method, and also keep this in mind. When we override the equal method, try to check every single field, okay, so that it's consistent with our implementation of the hash code. And over here for the hash code implementation, we call objects classes static method hash. And then you just plug in all of the instance variables. Okay. So this is the player class, very straightforward. And the second file is regarding the Java hash map. So it's basically the hash map. Okay, so here it's an interface because it's a key value pair. So that's why the generic we have key part and the value part. And over here we try to follow a Java hash map. So we try to follow the Java hash map data structure and provide of the corresponding methods. Okay, so that's why over here it's a little bit more complicated compared with the first example. So the method we are going to provide is we check if the key exists, contains key. And we also have the method to find the value, to check if the value also exists. And we have the get key function. Okay, so this put basically is add a new key value pair in the data structure, basically in the hash map here. Okay. And we have the remove, so they just remove the key, and here remove. So basically, you remove key, you also remove the whole record, okay, key value pair. So here we also say, okay, remove both with specified key value pair. And here you substitute with a specific key the old value with the new value. Okay, key we cannot change, okay, but value we can change. And this entry set is the complete set of this data structure. Okay, and the return type is just we make it a set of the entry type. Okay, and the key set is just the key. Okay, and of the value we also can store it in a collection. Then the size empty and the clear function. And the entry definition, it's the same as the first example. So the entry basically is for the key value pair. Okay, then here we have the class defined. So this is a concrete class and it's implement that hash table interface. Okay. So here we have the capacity as usual. We also have size, okay, to keep track how many items in this hash table and in this hash map, okay. And then we have an array, okay, and the array type is the key value pair entry, okay, from the interface. So the constructor pretty straightforward. So you start with uh, create a new array, okay, and the type is entry with the capacity. And the hash method is just with the specified key, then find the index. So this is to find the index uh, of the key value pair. Okay. So here we also not just to find the hash code, but also do the module operation. And here we try to see if the key exists. Okay, so you can call the get key and then check if it's not. And also contains a value. And for this contains a value because we cannot apply hash here. So what we do is we just do one by one comparison here. Okay. And then in this case, it's because the implementation here, we didn't use key to do the hashing to try to find the index. Instead, we do the linear one by one comparison. Okay. And then what next is to get the key. Okay, to get the key, we apply the hash operation and then find its index. Okay, so because it's going to return value, so with the key, then we return value. So from key, we find the value. So because over here, our implementation is a linear probing. And with linear probing, if you recall, the index start from I. If that position is already occupied, then we add 1 and then add 2, if you recall, for the new item. So that's why when we do the search, we also need to do the loop because it's not always going to be at I, the index. Okay, so I start from index, and what we can do is all the way plus the capacity, but this is going to go beyond the range, beyond the index range. So what we are going to do is we can do the module operation, okay? Module the capacity, okay? And then we can do get the key and then check if it is the key, okay? If it is a key, then you can get to the corresponding value. So here, when we do the find the key, it also involves the search from the index and all the way until we find it. Okay, or we just cannot find it. Okay, and then for this put operation, basically what it does is to add the key value pair into the map. Okay, into the map. So of course, we first find the key's index, and here it also involves the linear probing. Okay, and if at that specified location, the item, so the entry basically here here doesn't exist, then we need to create a new entry, okay, with the specified key value pair. And we also keep track of the current size. Otherwise, so if it is not a null, that means the key exists. Okay, if key exists, then we need to do the updating. Okay, so that's why here then we do, so we do the um we do the search. As it, we do the search. And so if so we do the search, so here again it involves the linear probing. Okay. And so it involves the module capacity to find the exact index starting from I, then I plus 1 plus 2, is it like that? But here it's from index, so then plus 1 plus 2, all the way to the capacity, okay? So uh, if key exists, what we are going to do is we are going to update the value. Okay, so over here, okay, if it's the capacity is not a null, and then the value is the key. Okay, we check if the key is equal. If the key is equal, okay, what we are going to do, we are going to update the value with the new value. And at the same time, so this is to keep track of the previous value, and we are going to return it. So that's what this method return value, okay. And then okay, so if the, so within the loop, okay, so if the module capacity is null, okay, then that means the key doesn't exist. Okay, if it doesn't exist, then we need to create a new entry. So over here, we have the linear probing. Okay, linear probing, so you find to find a new slot in the array. Okay, and then so the position is, remember to do the module capacity. Okay, because it will start at index. Okay, it may go beyond the range of the arrays, but if we do the module capacity, we guarantee the range will be between 0 to capacity minus 1. Okay, so that's why over here we do. And then we increment the size. Okay, and this is for our own tracking purpose. Okay, so this is how we add a new item, okay, using linear probing. And then we have the remove method. So for the remove, certainly you first need to identify if the key exists. If it doesn't exist, then you just directly return null. Okay, but even if it does exist, we get the index. But because the implementation is linear probing, we cannot just like previously in the other in the first example, okay, and over here what we needed to do, we need to keep looping, keep doing the iteration, then until we find the exact key. Okay, the exact key. After we find it, okay, then what we can do is then you can just assign that specific entry to null. Okay, then we remove it. And similar for the key value pair, okay, it's the same. You find the key, okay, and then we need to do the loop to get the exact key, both key and value match what we specify, okay, then we assign the respective entry to null, so we remove it. And for replace, okay, so replace is similar, okay, we find the index, then we do the loop, okay, and find the exact key and value, then we update, okay, update the entry basically here, okay. And for this entry set, what we do is we use a set variable. So this set variable, the type is entry, okay? And we create with a hash set. And then what we are going to do is we are going to loop through this array, okay? If the respective item is not a null, then we just add it to our set, okay? Then we can return it. So that's how we do it. The key set, then similar, we use a hash set, but the type is the type of the key, okay? Then we loop through, and if the respective uh, key value pair exist, then we get the key and add it to the key set. Okay, and then for the values, okay, we try to collect all of the values. And what we do is we use a collection for the variables. Basically, here is an array list, okay? Then loop through uh, this uh, array, okay, array of entry, if you recall. So, and then if the item does exist, then we get the value and add it to the respective collection, and then return it. So this is the value, and the next size pretty straightforward, empty and clear. Just so for the clear method, just clear the whole array. Okay, so just assign each entry to null. So that's the hash map. Our implementation of the hash map. And then let's see the driver, okay. For the driver, what over here we did is we have that baseball league player file, okay. Then it's stored in a comma separated value file, and it's each line is a player's information. So it has a player. If you recall, we have uh, the class is the player name and its league, and then its position and weight, height, something, weight, height, and age, if you recall this, so that's the player. So what over here we are going to do, we create a player array, okay? And we also create that Java hash map. Okay, so Java hash map. For this Java hash map, the key is name is a string, and the value is a player. Okay. So then we are going to do read line by line of the file, and we do some tokenization. And then after we tokenization, we extract the name league of the information. Then we create a new player and assign it to the respective slot in the array. So that's how we fill the array. And at the same time, what we are going to do is we are also going to add each player, okay, to the hash map, so called the put method. Okay, so we use a player's name, and this player is a value. So K is name, and the value is player. Okay, so that's how we add all of the contents, okay, to the hash map. Okay, and we try to get the whole hash map size, and it's a key set. It's a key set, okay, and the size we can all uh, output them. And what next we did is we try to see if there are same name players, okay. So what we do is here's the players, and we store it in a list, okay. And from this list, what we do is we try to get the name and then store all of it in a list of the name. And to try to find to try to find all of the uh, uh, names. Okay, if they're a duplicate, what we did here is um, what we did here is so this names is from all of the name from the league. Okay, so this is going to be the first uh, item of that specific name. And this is going to be the last of that name. If both are not equal, then that means you have duplicated names. Okay. If both are always the same, then that means the name is unique. Okay. So that's what we did here. And over here, we also try to find out of the values here, okay, and we can also find the size, okay. And what next we did is uh, over here, we try to find if some key exists, okay. If the key does exist, we try to call hash maps. So replace message, replace the name with another name, okay, with another name. So that's what we try to do here. And then what next we try to do is try to remove certain player, okay, from the hash map. And after we remove, we can check if we did remove, okay. And what next we did is we try to find another player, okay, and then get all these players' profile information. It's legal. So it's league, it's a position,